Today, I'm going to discuss the quantum numbers and give you some practice questions for AP Chemistry at the end of this video tutorial. So, in quantum mechanics, 3 quantum numbers are required to describe the distribution of electrons in hydrogen and other atoms. They are called the principal quantum number, and symbol is N. The angular momentum quantum number, L, and the magnetic quantum number, ML. These quantum numbers are used to describe atomic orbitals and to label electrons that reside in them. A 4th quantum number, the spin quantum number, MS, it describes the behavior of a specific electron and completes the description of electrons in atoms. So let's get started. First, the principal quantum number N. The principal quantum number N characterizes the size and the energy of the orbital. N can have integral values 1, 2, 3, up to 7. Look at the periodic table. You see here in the periodic table, I have 1, 2, 3, 4, 5, 6, 7 periods, 7 rows. And there is no 8 or 9 or 10. This is why values of N goes from 1 up to 7th energy level. The principal quantum number also relates to the average distance of the electron from the nucleus in a particular orbital. The larger the N, the greater the average distance of an electron in the orbital from the nucleus, and therefore the larger the orbital. Now let's take a simple example, the electron configuration of calcium. Calcium has 20 electrons to distribute. So the periodic table, here is calcium over here. So all of these orbitals over here are filled with electrons until we reach calcium, which is written as. For writing the electron configuration, I will write the link of that video in the comments below. So it is 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. So as you can see, where is exactly N, the principal quantum number? This is here. On the first energy level, we have just the S. On the second energy level, we have the electrons in the S and we have the electrons in the P. The S and the P. On the third energy level, we have also the electrons in the S and the electrons in the P. Now, we do have the electrons in the D, but for calcium, there are no electrons in the D because we don't have enough electrons. For the fourth energy level, we also have electrons in the S. So here, the number that we see written, these numbers are designate the principal quantum number. Yani where exactly or on which energy level these electrons are present. Now let's move on to the angular momentum quantum number L. The angular momentum quantum number L tells us the shape of the orbital. The value of L depends on the value of the principal quantum number N. And L is from 0 to N minus 1. So L is from 0 up to N minus 1. So again, it's the shape of the orbital. L will tell us, is this electron in S, or is it in P, or is it in D, or in F, or a G, or H? Now, I'm not going to reach to G and H, but I'm just going to say it in a simple way. So let's say, for example, electron is on the first energy level, okay? So when the principal quantum number N is equal 1, there's only one possible value for L because L is from 0 to N minus 1. So 1 minus 1 is equal to 0. There's only one possible value to L, which is 0. And 0 means S. When we are on the second energy level, L is from 0 to n minus 1. This is 0 to n minus 1. 2 minus 1 equal to 1. So I have two values for L. I have the 0 and I have the P. So this is why on the second energy level, I have the S, 0, and I have the P because L is equal 1. On the third energy level, so again, L is from 0 to n minus 1. So 0, n minus 1 is equal to, so I have also the n equal 1, the L equal 1, and the L equal 2. So on the third energy level, I have the S, the P, and the D. So I may have electrons in S, electrons present in P, and electrons present in D. On the fourth energy level, so it's going to be from 0 to 4 minus 1, which is equal to 3. So from 0 to 3. So therefore, I have on the fourth energy level 4 possible sublevels or orbitals, you may call them, S, P, D, and F. Okay? Now, let's give you a more bigger electron configuration, a bigger atom, saying the selenium. Selenium has 34 electrons. Where are those 34 electrons distributed? So if I write it, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p4. Let's just discuss the L over here. I don't want to complicate things. So when n is equal to 1, I only have L equal to 0. I mentioned it over here. So on the first energy level, you only see the S. Okay. When n is equal to 2, here n is equal to 2. I have L the 0 and L the 1. So this is L the 0 and this is L the 1. When n is equal to 3, so when n is equal to 3, when n equal to 3, I have L the 0, I have L the 1, and I have L when it's equal to 2, filled with electrons, and so on. So here, when n is equal, let's change color over here, when n is equal to 4, I have L the 0, and I have L the 1, and I have the D and the F. But here, there are no more electrons to fill the D and the F on the fourth energy level. This is why, because simply selenium has 34 electrons. So we stopped over here. Now, let's continue. The magnetic quantum number, ML, it describes the orientation of the orbital in space. And the value of ML depends on the value of L. So ML is from minus L to plus L. If you remember the example that I gave before in the electron configuration of selenium, in S, you see me only writing 1s2. Also, so let me write it again. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p4. Now, why we only write 2 every time we have S? That's the first question. Why we only write 6 or less than 6 when we have the P? Or why we write 10 next to the D? This is related to ML. So again, ML, it tells you the value, it describes the orientation of the orbital in space, and the value of ML depends on the value of L. It's from minus L to plus L. So let's explain it. Here, this is a very good example written to explain the ML. When the principal quantum number is equal to 1, Okay, so L is gonna be from 0 to n minus 1. Okay, so 1 minus 1 is 0. So there is only one value for L, which is equal to 0. And ML is from minus L to plus L. So if L is 0, therefore ML on the first, yani ML of L equals 0 is just 0. 0 means one orbital, means one box. This is why we always draw S as one box. And we can fill these boxes with electrons. Moving to the principal quantum number 2. On the second energy level, 2. So L is going to be from 0 to n minus 1. So I have a value of 0 and a value of 1. When L is equal to 0, ML is also 0. But when L is equal to 1, ML is from minus 1 to plus 1. So minus 1, 0, and plus 1. And that means 3 orbitals. And this is why P, when we write P, we draw P as 3 orbitals and we fill those orbitals with electrons. So if P is completely filled, 2 electrons here and 2 here and 2 here, that's a total of 6. This is why we always see on P written 6 and on S written 2. So if I go back to this electron configuration, on S I always have up to 2 electrons. And on P, I have up to 6 electrons. So it's 6 or less than 6. Depends on how many electrons you have. Let's take the example if I am on the third energy level, third principal quantum number. So L is going to be from 0 to n minus 1. That is equal to 2. So I have the 0, the 1, and the 2. If L is equal 0, we are in S. So it's the S orbital, and ML is 0, one box. If L is 1, I am talking about P in this case. So from minus 1 to plus 1. ML is from minus 1 to plus 1. This is why we have the P looking like this. And when L is 2, therefore the ML is going to be from minus 2 up to plus 2. So if I count from minus 2 reaching plus 2, I will be counting 5 orbitals. This is why you see the D in this form. 1, 2, 3, 4, 5 orbitals. And if I fill those orbitals with 2 electrons, D can contain up to 10 electrons. That's how we explain it. Okay? Now, the last or the fourth quantum number is the electron spin quantum number. Electrons act like tiny magnets. If electrons are thought of as spinning on their own axis as Earth does, their magnetic properties can be accounted for. According to electromagnetic theory, a spinning charge generates a magnetic field, and it is this motion that causes the electron to behave like a magnet. Let's look at this figure. This figure over here, it shows the 2 possible spinning motions of an electron, one clockwise and the other counterclockwise. Therefore, MS has 2 values, plus half and the other value minus half. So let's say helium, helium has 2 electrons. So here I have 2 electrons in the S orbital. So when I look at it, I always see 1 arrow up and 1 arrow down. And this is why in the box itself, whether it was S or P or D, I don't have more than 2 arrows in every square. Because in this case, 1 electron spinning clockwise and other electron spinning counterclockwise. Now I'm going to give some practice questions that are good for AP Chemistry. I'll solve these questions and explain them. Question number 1, state the number of possible electrons described by the following quantum numbers. N is equal to 3. And L is equal to 0. So how many possible electrons I can have? What does it mean L is equal to 0? L is equal to 0, meaning we're talking about S. And S is one box. And in the box, I can maximum contain 2 electrons. So my answer is 2 electrons. Now, B. N is equal 3. But they gave me L equal 1. So they're not talking about S, they're talking about P. The P which looks like this. So I have 3 boxes in P, each one containing 2 electrons, or I might draw them like this. So that's a total of 6 electrons. Question number C. The principal quantum number 3, the third energy level, and specifically they're talking about L2, meaning they're talking about D. And D has 5 orbitals. 1, 2, 3, 4, and 5. And they're specifically talking about the -1. This is the -2, this is the -1, this is the 0, this is the +1, and this is the +2. Because as I told you, ML goes from -L to +L. So they're specifically talking about this box. How many electrons I can put in this box? Only 2. But if they did not mention the ML, I can put 10, a total of electrons in D. Question part D. On the 5th energy level, of course, L is going to be from 0 up to 4. But here, they're specifically talking about the 0, meaning they're specifically talking about the S. The S, 5S. But they told me ML is -2. When L is 0, because ML is related to L, when L is 0, ML is simply 0. So here, it's not possible. Not possible. So the choice that they gave me over here, simply not possible. Another question. Give the N and L values for the following orbitals. So here we go. When I read 1s, here it gives me the N, and the letter here gives me the L. So since I see here 1, so over here N is 1. And since I read S, therefore L is 0. Again, 3, so N is equal to 3. And because I read S, meaning L is equal to 0. Another example, 2p. I read here 2, so it's the second principal quantum number, N is equal to 2. And because I read P, L is 1. 4, so N is equal to 4. And D, meaning L is equal to 2. 5F. 5 means N is equal to 5. And the F means L is equal to 3. Now, let's look at this question. What is the ML values for the following types of orbitals? ML values. Remember, ML, it's always from -L to +L. Okay? So, let's first write the L. If I'm looking at letter S, means L is equal to 0. If I'm looking at letter P, means L is equal to 1. L is equal to 2 when I see D. And L is equal to 3 when I see F. Okay, so here we go. If L is equal to 0, then ML is going to be from -L to +L, which is simply here 0. So the value of ML over here is 0. This is S. This is how S looks like. L is equal to 1. So ML has 3 values, -1, the 0, and the +1. This is how we draw the P. This is the -1 over here. This is the +1 over here. And this is the 0 over here. L is equal to 2. Therefore, ML is -2, 2 + 2, meaning -1, 0, +1, and +2. And this is why when I draw the D, I put 5 orbitals. Okay? So here's the -2, and here's the +2. When L is equal to 3, therefore I am talking about 7 orbitals. So it's going to be from -3 minus 2, minus 1, 0, plus 1, plus 2, and plus 3. Now, the last question in this video tutorial, write the values for the quantum numbers that represent the quantum numbers for the bold electrons in the following diagrams. So let's look at every diagram, and they want us to write the values of the quantum numbers, meaning how much is N, how much is L, how much is ML, and how much is MS, only for the electron given in bold, which is this one. So, to know the N, I need to read the number written over here. So it's a 3. To know the L, I need to look at the letter written, or I need to count how many orbitals. These are 3 orbitals. So simply here, because I read P, so this L is not the 0, it's the 1. Remember? S is 0. For P, L is 1. For D, L is 2. For F, L is a 3. So here I have P, therefore L is 1. Now the ML. ML is from minus 1 to plus 1. But this electron in bold, it's in the 3rd orbital. This is the minus 1, and here's the 0. Therefore, this particular ML, this one over here, is the box of plus 1. And since the spin is up, the direction of this arrow is upward, so the MS is plus half. Another example. Here we go. I have 5S. So N, L, ML, and MS. To know the N, I look at the number over here. It's 5. To know the L, I read the letter designated over here. That's an S. So L is 0. ML is always related to the L. And since L is 0, therefore this ML is equal to 0. And it's just one box. Now the MS, I look at the direction of the arrow. It's pointed downward. And MS has 2 values, either plus half when the arrow is upward or minus half when the arrow is downward. And this one is downward, so MS over here is negative half. 2 more examples. For D orbital, and this is the electron we're talking about. So N over here is, the number over here is 4, so N is 4. L is related to the letter over here, and the letter over here is the D. Therefore, the L is 2. The L is 1. Okay? Now, so this one, sorry, my bad. So the L is equal to 2 because I have D. So as I said, for S, L is 0. For P, L is 1. For D, L is 2. For F, L is 3. Now the ML depends on the L that you wrote. So you wrote 2. So the ML is going to be from minus 2 to plus 2. Now the electron in bold is in the first box of the L orbitals. So ML over here is specifically negative 2. And the arrow is pointed downward, so it's negative half. Last question, part D. I read 3, so N is 3. I'm reading L, so I'm reading D, so L is 2. Now, ML related to what's written over here. ML is 2. L is 2, so ML is going to be minus 2, minus 1, 0, plus 1, and plus 2. But let's look at the figure. We are over here. We're not in the minus 2. We're not in the minus 1. We're not in the plus 2, nor in the plus 1. So ML in this specific example, because I see the figure, ML over here is the 0, 1. And the arrow is pointed upward, so it is plus half. Thank you for listening. If you have any questions, please write them in the comments, and I'll be glad to answer you. For other related related videos, you can also see the description below my video.